In our final lesson of chemistry, for new material, of course, we'll always review, but we are going to look at titration. And titration is piggybacking off of neutralization reactions. And it's determining an unknown. It's actually a really cool process to do it. So the general process of determining the molarity of an acid or a base is through an acid-base reaction, a neutralization, called an acid-base titration. And if you watch the video, you kind of see how a titration process works. But really, it's a very slow process. You have to figure out what you know, and then neutralize that thing with the opposite. So if you start with an acid, you neutralize with a base. If you start with a base, you neutralize with an acid. And it's a very long process. You have to be, it's very slow, but it's very methodical, but it's very, very important. The known reactant molarity is used to find the unknown molarity of another solution. The solutions of the known molarity are then used in this fashion is called a standard solution. So once you, if you know your molarity, that's your standard, okay? And your unknown is what you're trying to find. In a titration, like I said, the molarity of one is known and the other one is unknown. You have to know the molarity of one to do the other. If you don't, then this isn't going to work. So I have a problem for you to work through. If I have 15 milliliter sample of a solution of sulfuric acid, which that's what H2SO4 is, and I have an unknown molarity, or of an unknown molarity. So my sulfuric acid has some type of molarity that I don't know. I'm going to go ahead and do a titration with 32.4 milliliters of 0.145 molarity of sodium hydroxide. So my acid is unknown, my base is known. And I'm going to use bromothymol, bromothymol blue. It's an indicator. You watched a video on indicators a couple days ago, to that endpoint, which means once I switch my solution from basic to neutral, that's its endpoint, I'm going to stop. Based on this titration, what's the molarity of my sulfuric acid solution? So here is my reaction. Again, I need a balanced equation. So H2SO4 plus 2 NaOHs yields Na2SO4, or sodium sulfate, plus 2 waters. So the first step is to find your number of moles. Okay, so solve for moles. You have molarity, you can solve for moles, okay, of your base. So you're going to solve for moles of your base, okay, because you have your molarity and you have your volume, right? So molarity equals moles over liters, okay? So your molarity, or your moles are X, your molarity is 0.145 m, and your liters, again, it's in milliliters, so I'm going to have to convert this by dividing 32.4 divided by 1,000, gets me 0.0324. Since that's on the bottom, I multiply each side by it, and I get 4.70 times 10 to the negative third moles. It's a really small number, okay? So those are my moles of sodium hydroxide. My next step is then to do that mole to mole ratio and convert stoichiometry through stoichiometric measures, go from my moles of my base to my moles of my acid using my balanced equation. So my 4.70, that's my moles that I solve for. That's my moles from step 1. I'm going to then use my molar ratio. NaOH is going to go on the bottom because that's my given. And I'm going to look here, and my balanced equation has a 2. And then I'm going to put my moles of H2SO4, and that goes on top. And if you notice, I don't have a coefficient, so it's just 1. Okay, so I'm going to take 4.70 times 10 to the negative third, multiply it by 1 and divide by 2, and I get 2.35 times 10 to the negative third moles of sulfuric acid. Now, if I just needed moles, I could stop. But I got to go a little bit further because I do need molarity. So I'm going to do my molarity this time. Okay. And I'm going to use that same equation, m equals moles over liters. Okay. So in this case, I have my moles of 2.35 times 10 to the third, negative third. My liters is given to me in my problem as 15 milliliters. So again, I got to convert to liters by dividing by 1,000, and I get 0.015 liters. I'm going to take 2.35 times 10 to the negative third divided by 0.015, and I get 0.157 molarity. So that is the molarity I need for my sulfuric acid if I do this titration. Okay? And that is how you do titrations. And that is all you have needed to learn from chemistry. Congratulations, you have finished all of the new content of the chemistry course.